objects don't want to change what they're doing. We said that an object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. In other words, if the forces are balanced and they're canceling each other, the object will keep on doing what it's doing. Newton's second law tells us what happens when the forces are unbalanced. Newton's second law states that objects move only when unbalanced forces are applied. And the more force we put, the faster the acceleration or the faster the change in its motion. An unbalanced force is a force where it is greater in one direction than in the opposing direction. Consider the two pictures of the people playing tug-of-war. Assume for a moment that we're starting from a position of standing still, so our velocity is 0. In the top picture, both teams are pulling in opposite directions, but with the same amount of force. Force is measured in newtons. We're going to talk about that in a minute. In the top picture, we're pulling in the backwards direction with 300 newtons and in the forward direction at 300 newtons. So no one's going to move. This is balanced. In the bottom picture, however, the team on the left is now pulling with 400 newtons of force, and the team on the right only has 300 newtons of force. The people will now move to the left. There is 100 newtons of net force, the difference being 100 newtons of force to the left. This is what we consider to be an unbalanced force. So I wanted to talk about newtons. Force has two components to it. It has the mass of the object and the acceleration or the rate that its velocity is changing. Mass measured in kilograms and acceleration is measured in meters per second squared. If we multiply them, we get a unit called a newton. 1 newton is the amount of force required to move a 1 kilogram object, or accelerated, at 1 meter per second squared. Gravity pulls down objects towards the Earth at 9.8 meters per second squared. And eggs are very small objects. But the amount of force that an egg puts on your hand because of the acceleration of gravity would give you an approximation of what it feels like to have 1 newton of force. So how much force would be required to move a 10 kilogram object and accelerate it at 3 meters per second squared? Well, multiplying the mass, 10 kilograms, times the acceleration, 3 meters per second squared, we would need to apply 30 newtons of force. An impulse is the change in an object's momentum. For example, if we suddenly push on a stationary object, a football player, for example, being tackled, or a cyclist using his brakes to stop his bike, we're having an instant force that is changing the momentum. We're changing what the object was doing. In order to change the momentum, a force has to be applied over a period of time. The longer the time involved, the less force I need to apply. For example, consider a car coasting to a stop slowly versus one stopping suddenly when the brakes are applied. I need a lot more force to stop my car quickly than I do over a long period of time. To practice Newton's second law in your work package, I'd like you guys to complete task 6. Also, I'd like you to head over to the physics classroom, and I'll include the link. And there's a great interactive demonstration that you guys can do to help you understand Newton's second law.